Welcome to The Explainer. Today, we're breaking down an incredible story of cosmic detection work. Okay, let's dive right in. What you're looking at here is Messier 70. It's a globular cluster, which is basically an ancient, jam-packed city of stars. And deep inside that stellar metropolis, a team of astronomers went on a hunt for something very, very special.
So before we get into the how, we've got to understand the what. What exactly were these cosmic detectives looking for?
They were hunting for these things, millisecond pulsars, or MSPs for short. Now just think about what they are for a second. They're the spinning corpses of massive stars, and they're whipping around so fast they blast beams of radio waves across the universe like a cosmic lighthouse. But here's the kicker. They are some of the most stable, precise clocks we've ever found, which makes them perfect laboratories for testing the absolute limits of physics, like Einstein's theories of gravity.
And if you want to find an MSP, the absolute best place to look is right where we started, inside a globular cluster. I mean, the sheer density of stars in there, it's just mind-boggling. It makes all the weird stellar interactions you need to create a millisecond pulsar way, way more likely to happen.
All right, so you've got your target, but how on earth do you even begin to look for a tiny spinning star in a city with hundreds of thousands of them? Well, you're going to need some pretty special tools.
You need a seriously powerful ear to the cosmos. And in this case, that ear is the upgraded giant meter-wave radio telescope in India. The team, working on a project called the Globular Cluster's GMRT Pulsar Search, or GCGPS, used this incredible instrument to just listen. To listen for the incredibly faint radio whispers from these pulsars.
The method itself sounds simple, but it's a bit like cosmic fishing. You point your giant telescope at the cluster, you cast out two different electronic nets or beams to listen in, and then you just wait for hours. And after all that, you've got to sift through a mountain of data, all cosmic static and noise, hoping to find one faint but perfectly regular repeating pulse. Now here is the really clever part of their whole technique. They used two views at the exact same time. The first is a wide-angle beam that gives them a general look at the whole cluster. But the second beam, that one uses more of the telescope's power to create a really tight, super sensitive view that's zoomed right in on the cluster's core. It's kind of like using a wide-angle lens and a telephoto lens at the same time, just to make sure you don't miss a thing. So in May of 2024, while they were observing Messier 70, the GCGPS team got a hit. Actually, they didn't just get one hit, they got three. And these were the very first pulsars ever found in this cluster. And check this out. What you're looking at here, these aren't artists' impressions. This is the real deal. These are the actual signals they found. After all that searching, these are the clear, repeating pulses, the literal heartbeats of dead stars, cutting right through all that cosmic noise. It's just absolutely beautiful.
They named their new discoveries M70A, B, and C. The fastest of the bunch, M70A, is spinning over 250 times every single second. Just try to wrap your head around that.
Then there was M70B. This was the strongest signal they picked up, rotating every 4.44 milliseconds. And finally, the third one, M70C, was a bit fainter, but it was definitely there, with a spin period just over 6 milliseconds. What an incredible haul from just a single observation. So here are the vital statistics for our three new cosmic lighthouses. You can see their spin periods, but look at that other number, the dispersion measure, or DM. So what's that? Well, you can think of it like a cosmic odometer. It tells astronomers how much interstellar gas and dust the pulsar signal had to plow through to get to us, and that is a key piece of evidence they use to figure out how far away it is. For the first time ever, Messier 70 was officially on the pulsar map. But hold on. Finding a signal is one thing, but knowing exactly where in that insanely crowded city of stars it's coming from, yeah, that's a whole different ballgame. Look, to really study these things and unlock the secrets they hold, you need a precise address. You have to be able to stick a pin in the map and say it's right there. And this is where the detective work gets really, really clever. Their first huge clue came from comparing those two beams we talked about earlier. They looked at the signals from all three M70 pulsars, and they noticed something amazing. The signal wasn't just in the more focused beam, it was 40 to 60% stronger. And that right there tells you almost everything you need to know. A signal boost that big could only happen one way, If the pulsars were hiding right in the bullseye, deep inside the cluster's core where that super sensitive beam was pointed. If they were anywhere else, farther out, the signal would have been weaker, not stronger. Brilliant. Okay, so next, the astronomers made a radio image of the cluster to try and actually see the pulsars. But of course, it's never that easy, is it? There's this big, bright blob of a source right near the center, kind of obscuring the view. But look closely. You see that faint little source marked with an A? It's a tiny, compact dot, sitting right in the cluster's core, exactly where their dual beam analysis said the pulsar should be. This little dot just became their prime suspect. So, let's take a step back. What's the big takeaway from this incredible piece of cosmic detective work?
What we've just seen is a fantastic piece of science in action. I mean, not only did they discover 3 pulsars for the first time ever in M70, but we got to see how their clever dual beam setup gave them the first critical clues about where they were, and then how radio imaging helped them zero in on a suspect. It's a complete story of discovery, from the first faint signal to a dot on a map. And this really gets to the heart of why any of this matters. As the discovery team themselves put it, pulsars in these crazy dense environments are powerful probes for studying gravity. They let us study physics under the most extreme conditions you can imagine, conditions we could never, ever create here on Earth. Each new one is like a new key that could unlock some fundamental secret about how our universe actually works.
And the GCGPS survey, it's still going. They are still searching more and more of these ancient star cities. And that leaves us with a final, really exciting thought, doesn't it? What other extreme, bizarre, and incredible cosmic objects are still out there, just waiting for us to find them?